Hi guys. So today what I'm going to do is I'm going to show you guys how we can use MATLAB and Simulink to solve some of those differential equations that we have been deriving from the beginning of the semester and work with them. So first of all, when you open your MATLAB, you might not see the same configuration that I have, okay, because my view is set to the default MATLAB view. Yes, so you can change your view by going to View Editor, okay, and then View ribbon here and change your view in a way that you like. For instance, if you just want to see single column or some custom views, okay, you can go ahead and generate those guys, okay. But for me, I'm happy with the default MATLAB view, so I can work with this. Now, if you look at my screen, you see that I have some files here and a current folder. And this current folder is actually the working directory of MATLAB that I have here. Okay, so for instance, right now I'm in the summer 2025 and mechatronics course and the codes. Yes, so I want to change this one. I would basically put the browse for a folder. Okay, and with this one, I would go to summer 2025. Okay, and I would go to mechatronics. Sorry, the ME384, and this time around, I'm just going to make a new folder, okay, and I'll call it as MATLAB codes. Yes, MATLAB codes for ME384. Now, let's work with this one. Okay, so I'm going to go to this one. Okay, I'm going to select this folder. This is going to be my current directory. Okay, and you see that this current directory right now is empty. Then I have here my editor section, which the editor is the part that I would write some codes in this one, okay? And this is just like a Microsoft Word for you per se, yes? It's just a text editor. And then below that, I have the command window. If you follow my cursor here, you see that I have the command window. And in this command window, I can basically command the MATLAB what to do. And at last, I have the workspace here, which is basically the link between my computer and MATLAB interface. Okay, so whatever I define as a variable in MATLAB, it's going to appear here. Okay, let's give you guys an example. For instance, I would say a equals to 1. Okay, and when I put a equals to 1, you see that a will appear in my workspace. Okay, and the beauty of this workspace is that every application in MATLAB will have access to the workspace. So you do not really need to define a separate memory for those applications. There are specific parts that you need to define a separate memory for them. You do not encounter them in this course. Okay. Regardless, let's clear my window with CLC, okay, and start the Simulink model. Okay. So for starting the Simulink model, I'm just going to type here as Simulink. Okay. And press enter. When you type Simulink here, then the Simulink browser will open up. Okay, and in this part, you can select many things. Okay, what I would do is I would like to have a blank model. Okay, so I would like to start everything from the scratch. When you click on the blank model, then you will have exactly a blank model. It's a blank page. Yes, and right now this is your canvas. You can start painting on this canvas. Okay. So you need to bring blocks from somewhere to this blank canvas, basically, yes? So if you look at here in the top in simulations, okay, and the library browser, if you click on the library browser, you see that library browser will give you some options. The first option is Simulink, okay? So let's click on the Simulink, okay? And you see that Simulink has some subfolders as well. So most of this time, we can find all our blocks in commonly used blocks. Okay, so it has a list of blocks, okay, that we're gonna use most of the time. For instance, in our lecture, you see that we had a junction, and in MATLAB, they call it a sum, or they have scope, or many other things. Okay, for instance, they have a gain here, okay, and also the integrator. And if there is something that you cannot find it here, okay, then you can search it here on the site, okay, and it'll give it to you, okay, it will bring it and find it for you. For instance, let's say that you want to find the transfer function. Yes, And when you search for transfer function, okay, it takes some time for MATLAB to find that one. And then there you go, you have the transfer function, okay? And eventually in time, when you get comfortable with MATLAB, you see that your transfer functions are in continuous, okay, and you go directly to continuous and find the transfer function here. Why? Because you're experienced in that. So this is one way to access these blocks in Simulink. The other way is basically just, let me close this library browser. The other way is just double clicking on the blank model, okay, and then write down the name. Let's say transfer function, yes, and it will bring you the transfer function block, okay, so you can actually just use this one, okay, and just by double clicking with that one, it'll bring you a transfer function here. Now, look at the transfer function. You see that your transfer function has is a block. Yes, if you double click on that, you can set the parameters of that transfer function. For instance, for the numerator, it has only one. So they are the coefficients of the polynomials in the numerator and the denominator. Let's say that you want to have the numerator as 1 and 1. Okay, let's see how it changes. Okay, and when you apply this one, you see that right now in the numerator of your transfer function, you will have s plus 1. In the denominator also, you will have s plus 1. Okay, if you want to change it to s plus 4, you just change the second one here to 4. Okay, and when you apply it, you see that right now you have s plus 4. Let's say that you want to find s squared plus s plus 4. So you just add one coefficient for s squared. Yes, so it's going to be 1, 1, 1. Yeah, so a time domain realization, it says that the numerator should have always less uh, order as the denominator. Okay, so let's give this one as 1 plus 4 and change the denominator. Okay, so we are going to add one pole to this system. Okay, so I would have it as 1, 1, and then 4. Okay, and when you do that, you see that your transfer function right now changes to a numerator over denominator. If you make this one a little bit bigger, okay, then you see the transfer function inside this, s plus 4 over s squared plus s plus 1. So you just gather the coefficient of these polynomials, yes? Now let's say that you want to have s cubed plus s plus 4. So you need to account the missing coefficients. So if you have s cubed plus s plus 4, then the coefficient for s squared is missing, yes? So you just have it as 0 here, yeah? And if you do that, for instance, like this, you see that right now it's going to be s cubed plus 0s squared plus s plus 4. So this is just one small detail that you need to keep in mind, yes? Okay, so then you bring all the blocks, okay, from your code, okay, and then connect them together and run the simulation, okay? But note that, guys, Simulink is a numerical software, yes? So you cannot work with L and M directly unless they have a value, okay? For instance, one of the examples that we did in the class was the block diagram for this simple RL circuit in series, yes? So if you guys remember, we had the transfer function here and then the R block here, yes? Now you want to simulate this, okay? We're going to have a transfer function here and an R here, okay? And then we are going to connect them together. However, Simulink is a numerical solver. It cannot have L without a value. So you need to define L and R for this system, okay? So how can we do that? We can go to your MATLAB, okay? And in MATLAB, you can open an M file. You go to home and then new script, yes? You open an M file. And in this M file, what we can do is we first clear the screen, clear the memory, okay? And then also close all the open plots. Then let's say give a number to L. Let's say that L is 100, okay? And let's give a number to R as well. Let's say this is 10, yeah? And when you want to run this, okay, MATLAB, you go to the editor and click the play pause button here, run, yes? Okay, and MATLAB asks you to solve this, okay, to save this. We're gonna save it as example 20 code, Yes. And note that in your file name, there is a specific characteristic that you need to follow. For instance, you cannot start the file names with numbers. You cannot have spaces in your file names. Any spaces, you just use a underscore. Okay, and some other things. You cannot use specific characters in your file names. Okay, regardless, let's say that I save this one, okay, and I run it. And when I run this code, you see that the value of L was 1, the value of R was 1, and this is going to be here, appearing here. L is 1, R is 1. This is in my workspace. Now, my workspace is a shared space between MATLAB and Simulink. So whenever you go back to the Simulink file, okay, you will have access to the workspace as well. So now let me just copy a screenshot of the transfer function that we were working. Okay, so let me just get a screenshot of this. Okay, and bring it down. Yeah, so I'm gonna bring a screenshot of this. So I'm not gonna toggle between these two windows all the time. Okay, so let me just copy this screenshot here. Yeah, now I'm gonna make the same block diagram in Simulink right now. Yes? Okay. So first of all, I need a transfer function. You see that? Here I have a transfer function. The numerator of this transfer function is 1. The denominator is ls plus r. So click on this one. Okay, the numerator, we just have 1. So it's going to be 1. The denominator is ls plus r. So the coefficients are l and r. You see that? Whenever you put these coefficients as L and R, MATLAB will basically go ahead and read them, the value for them from the memory. Yes? Okay. Now you apply, click, okay, and this is going to be okay. Yeah. So this is your first transfer function. Now let's bring the value of the gain. Yes. So I'm going to bring the value of the gain. So let's say that I need a gain here, and I'm going to click on this gain. Okay. And I'm going to put it here. Okay. And for the value of this gain, I need an R value again. Okay, so I put it as R. Okay, and this is going to be an element multiplication. Okay, since this is a scalar, and click on OK. You should be done. Yes. Now the only thing that you need to do is you need to connect these two guys to each other. Yes. So you can basically go to the terminal of the transfer function and get a branch by holding down the right click and connect it to the next one. Okay, or another way is actually this is an easier way. Okay, let me just get rid of this guy. You click on the first one, hold the control down, click on the next one. Okay, and they're going to connect them together. Okay, so in Mac it's command, in Windows it's control, holding the control down. Yes. Now look at this. You have the model. Yeah. Now you want to see what's going on inside this model. Let's put a scope here to see what is going on inside your model. Okay. And I'm going to bring the scope. Okay. And I'm just going to connect them together. For this scope, I'm just going to name it as E out. Yes. So E out of S. Yeah. And for the input, we can go to the sources, we can go to the library, okay, and go here to the sources, okay, and you can pick whatever input that you like, okay. So for instance, you can use a white noise, or you can put a pulse generator, or you can use a sine wave. Okay, for me, I'm just going to put a sine wave by dragging this one, okay, to the model. Now it just takes some time for this one to come in, okay, and then I connect them together. Now my system is complete. Before going forward, guys, if you want and you like, okay, you can annotate these signals, okay, and give them some numbers, okay, by clicking and putting some information here. Okay, for now, this is a very simple problem. I'm gonna neglect that part, okay, and let's see what we have here. When you play the press the run button here, it's gonna, you see that it's gonna compile your code, Okay, it's going to compile your code and it's going to run it. It's going to run it for 10 seconds. Yes, it's going to run it for 10 seconds. Okay, and for now, when you click on when the run is complete, you see that you have it ready. The run was done without any error. When you click on the scope here, double click on the scope, you can see the result of your simulations. Okay, so this is the result of my simulation. So this is the output of the system. Yes. Now, if you want to see the input of the system as well, you can get a branch from the input, okay, and pass it through a scope. For getting that branch, okay, let me just bring another scope here. Okay, so for getting that branch, okay, I'm gonna right click on the signal, okay, and I'll get a branch, okay, and then I'll drag it to the scope, okay, and this is gonna be my input signal, input voltage basically, okay. Now, if you run it again, okay, you see that again, it's going to initialize, it's going to compile. Now it's ready. You see my cursor here. If you double click on the input signal, you'll see the input signal as well. Okay, if you double click on the output signal, you'll see the output signal as well. Okay, so if you want to see both of them at the same time, you can see both of them at the same time. Okay, now there are a lot more variations that we can get with these guys, okay, that we're going to talk about them in different videos, okay, but this is your first model. In the next video, we're going to do the same thing with the integrator. I hope you guys enjoyed this video.